Hi, my name's Jim Brown from TechClarity, and welcome to this webcast today. We're really excited to bring you this interactive conversation on the role of simulation technology and in digital twins. This is actually the fourth in a series of executives webinars that have been brought to you by AMC Bridge. We're excited to continue this conversation. We've got a fantastic group of experts lined up today, and look forward to your questions as well. If you can, enter any questions that you may have in the Q&A tab on your console as you go through, or if you have any technical difficulties, you can also ask those in there. We'll be recording this webcast and really look forward to your participation, but also the participation of this great group of experts. Before we get started, Igor, I'd like to just turn it over to you for just a minute.
Thank you, Jim, and welcome everyone. Thank you for joining us for this executive series. As you probably saw in our invitation, as you probably know, AMC Bridge technical team is located in Ukraine, and as we all see in the news, the whole country, all people in Ukraine, and our team is going through the very tough times, and at least part of our team endures quite difficult conditions, but they continue to do their job and serving our clients, providing our services to the community. And we see a tremendous support and tremendous understanding on the part of our clients, of our former clients, and community overall. So despite this kind of difficult situation, we decided to continue our executive series to, so to speak, give back to the community, to look forward to the time when I don't need to do this introduction and we continue to work as we used to work. So this event is a part appreciation of our engineering community and support it gives to people in Ukraine and particular to our team. So thank you again for your support, and I hope you enjoyed this conversation. Thank you.
Great. Thank you, Igor, and I'm sure all of our hearts go out to the people in Ukraine. Let's go ahead and start this conversation with some quick introductions. My name's Jim Brown from TechClarity, and we're an independent research firm. We've been fortunate to be able to moderate these panels. We do quite a bit of research into simulation technology as well as to digital twins. And my role, though, today is just to ask the right questions to really let these experts share their views. I'm going to have each of you, if you could, just share a little bit about your role, your name, your role, what your company does, and any brief points about how you are supporting or working on simulation and digital twins. So let's go ahead and actually I'm going to start from left to right here. Igor, if you would just go ahead and share a little bit about who you are, what AMC Bridge does, and your roles in simulation and digital twin.
Igor Zinman, I'm a president of AMC Bridge. We organized this executive series to exchange ideas on hot topics in our community. So AMC Bridge is software development consultancy. So our role is to solve customers' problem using software technologies and approaches. And we see more and more interest in more and more projects where people try to implement digital twins, and we see an evolution of these projects typically involve multiple technologies, and lately simulation became a very important part of the digital twin considerations, or at least planning, and in some cases it goes into implementations. So we kind of interested to hear if our observation of the industry is true and what technology could be involved and what areas could be covered by this simulation integration into digital twin approach.
Great, thank you, Igor. Yigal, we've known each other for quite some time. Maybe you can introduce yourself and your role with digital twin and simulation.
Hey, Jim. Igor, thanks for inviting me to this. Yeah, Igor Kaptan. I'm the GM for software for GE Additive. We produce additive solutions in metal. Next time you get on a plane and you see a latest GE engine, you should be aware that over 30% of it is 3D printed and it's FAA approved. With digital twin, we see three different categories. And the first one is the typical one, which is the assets for IoT purposes, for maintenance purposes. The second digital twin category is to be able to do what-if scenarios. And the third one, which is unique to additive, it's a full simulation of the physical process. Because in different from AEC, for example, in additive, we change the asset because the geometry that comes in changes because of the simulation in order to generate it in the end. But we'll talk more about it as we go.
Great, thank you, Yigal. We turn over to the first of our Davids, Dave Heine.
Pleasure to meet you all. Warm welcome from my side. I'm David. I'm co-founder and CEO of SimScale. SimScale is a cloud-native platform that makes engineering simulation truly accessible at any scale. And so we believe there's a lot of innovation that can be unlocked by leveraging simulation earlier, broader, more intensely. And for the sake of this webinar, also later in the product lifecycle to unlock innovation. And to that end, we've built a platform that supports that. I guess the most touch points we have with digital twins is around our API. We believe that a lot of the simulation workflows of the future, there won't be a simulation engineer clicking around assigning boundary conditions, but those simulation workflows will be triggered automatically from digital twin solutions, from other processes. And so to that end, we've built, we made our entire functionality accessible programmatically via a modern RESTful API. And we see that API being leveraged in a lot of actually quite different interpretations and instances of digital twin solutions, but all of them sort of combining measurements, data from the field, and driving simulation workflows with it. Jim, you said we have 15 minutes for this introduction per person, right? So I guess I'll cut it short here. So just back to you, Jim.
Thank you. Let's move on to our second David, Epic Dave.
That's a good name. Hi, everyone. My name is David McCall. I work within the architecture enterprise team at Epic Games. For those of you who are unfamiliar, Epic Games are the creator of the Unreal Engine, which is the most powerful game engine on the planet. And our position in digital twins is really for the same reason that we're in games. It's about creating that visualization, communicative layer between end users and that complex back end of simulation. So great that other David went first, because part of what we see people using the engine for is an aggregated place for all these API connectors and create bespoke experiences that allow end users and stakeholders to navigate those complex data sets in very simple ways.
And thanks that you didn't call me non-epic David. David, appreciate it.
You're welcome.
Great. Ivar, if you would introduce yourself and experience with digital twin and simulation.
Hello, everyone. My name is Ivar Foster, located here in Chicago. I work for an amazing company called Built Worlds. And what Built Worlds does, it's a global network that connects industry leaders within the AEC industry to understand how to leverage technology to further the efficiency of project delivery. And we work with both the technology adoption leaders of contractors, engineering firms, and specialty contractors. And on the other side, we work with the solution providers who want their solutions to be adopted, enhanced, and pretty much spread everywhere it can be. So my role is to look at trends and adoption specific to project delivery and prop tech, as well as understanding the level of satisfaction of the technology that's being leveraged across the board, in addition to the level of functionality that solution is actually providing for the contractor and engineering firm. My experience directly with digital twins and simulation is I used to work for a company called Pepper Construction, and we kind of spearheaded the laser scanning and reality capture department for scan to BIM efforts. A lot of projects that we did here in Chicago, like Wrigley Field, Starbucks Roastery, leveraged the scan to BIM project delivery method. And in particular, with simulation, we started to manipulate scan data into VR environments for training and for allowing the owners to see mock-ups in virtual reality versus actually building it, which would save a ton of money. So that's my background there.
Thank you, Ebert. Xingwei, would you introduce yourself and a little bit about your role with simulation in the digital twin?
Thanks, Jim. I'm working for a company, a Donaldson company. We are located in Bloomington, Minnesota. Donaldson is a global leader in filtration industry. We provide technology differentiated product and service in aerospace, manufacturing, food and beverage, construction, life science, and many, many more. So our vision is advanced filtration in a clean world. Okay, so we invest incredibly in number of the technology. As you can imagine, majority on material science, but also in intelligent filtration as well as digital modeling. I just want to show you, this is a very simple mask. We actually manufactured that in the past 2 years to help overcome COVID-19 crisis. The simple product like that have incredible complex multi-physics. You know, you can think about structure, fluid, particle chemistry in reaction. So we have a digital modeling strategy to help us to really understand as small as a nanometer or as big as a factory, like tens of hundreds of meter scale. In addition to that, on digital twin, we also want to understand our product in real life. So we have a number of business related to IoT and the digital twin. We receive the information of our product in real field, including manufacturing, truck, construction, many, many different industry. So yeah, we are very excited in this journey of the digital twin as well as simulation.
Great. Well, I'm excited about this group. I think we've got a group that's very diverse, but also very very experienced. Let's start out with a little bit of the importance of digital twin to business. Our research shows that 2/3 of the manufacturers view digital twins as either important or critical to achieving their business strategy. So that's a very high level of importance. You know, it's not just a tool; it really is driving business level performance. And we see the same kind of level of priority in architecture, engineering, and construction companies as in manufacturing. Why is the digital twin so important to business performance? Igor, we're going to give you the first word on this one as well.
I'm not sure if you said Igor or Ebert.
Sorry, Igor. I know Igor, Ebert, and Igal. We've got. I'll have to enunciate. My Davids aren't my only issue.
Thank you, Jim. We are typically called upon when people see the problem at hand and ask us for to solve this problem and propose this solution and implement it. So it's a bit hard for me to say why exactly businesses are considering it, but my guess is it's basically a new step in developing product, but it's also a new step in maintaining and extending the problem. And Igal indicated this quite well when they said that what if scenario becoming more and more important. And if we think a little bit back, it was a kind of revelation when we got the opportunity to say to model what if on a model. So you got your 3D model and then you what if and check it with simulation. The digital twin in my mind is kind of a step forward, but we do the same thing with already manufactured product. Is it a building or is it a complex mechanical system where we try to get it as build information captured in twin digital twin representation, and then applying simulation via testing what if scenarios, or what happens when the kind of after 1,000 hours of usage, this product kind of changes the behavior, changes the property, etc., etc. So I think it's a next step in a digitalization process, and many kind of gives up tremendous opportunities. Not of all of them, I think, are known at this point, but I think it's a logical progression of digitalization in our industry.
Yeah, couldn't agree more. Igal, if you can continue on and let us know your thoughts, in terms of why digital twins are so important.
I think the amount of data that we have to handle today, the dependencies, it's just too big to do it in any other way. And you need digital tools to help you do that. But then besides the 3 different types of digital twins, I'll make another branching in there, and that is a statical digital twin and a dynamic digital twin. And you see in many cases, people treat digital twin as a static snapshot in time of the assets, and they're trying to manage it in parallel. It has its own value, but I think keeping a dynamic digital twin to be able to do what if, but also have it totally updated, so you all different people are touching the same data and propagating it up without the need to export files and bringing them all together into one, are becoming even more and more critical for any industry, regardless of what it is.
Great, thank you. Dave Heine.
You need to signal me with the eyes that I can unmute, Jim. So I think I'll pick on Igor's last sentence. To me, it also almost seems like this logical consequence of everyone, I think, has understood digital transformation is real. A lot of value for organizations producing hardware assets, be it architecture or manufacturing. A lot of value will be created in the digital world. Software eats the world, and I think everyone understood that, and everyone is busy digitizing the own organization. And I think the digital twin is just like this natural progression of this, because as organizations producing hardware equipment, like connecting this with the digital representations, as Igal just said, ideally in a dynamic way, is just this natural, this logical next step. And I think we've seen it in other industries. The organization that understands the usage of its products, could be software products, better, the needs of the customer better, can feed this faster into the own design, into improving the operations of that asset, I think is the organization that will innovate faster and ultimately win in the marketplace. So to me, it just seems a natural cornerstone of the digital transformation of organizations producing hardware.
Great. All right, next Dave is up.
Yeah, Big Dave, that's fine. I mean, I think one of the obvious sort of reasons on why it's important to business performance is money. I think the most influential decision that is made in real estate at the moment is around ESG, which is environmental, social, and governance policies. And there's a call to be more transparent on your strategies on how your building will operate in the long term and how your building will impact those kind of rules. And there's a lot of funding and requirements around that. And I think that is a key place where digital twins and simulation actually will allow that transparency and allow what's often been mentioned already as being the what ifs, to explore the potentials of where it goes. So I think that's an important part of the business.
Very good. Ebert?
Yeah, I'd have to agree with what was said from all the other speakers. Specific to what I've seen in construction for digital twins, having an accurate as-built model of what was actually installed versus what was planned is massively important for the standpoint of potential further tenant improvement projects. Talking about commercial projects, K through 12, hospitality, having a replica of what was installed and being able to hand that over during turnovers of tenants, or even handing over when you're selling the asset off, I think elevates the not only the quality of the records that have been held for that asset specifically, but also the value of those digital records being sold in combination with the physical asset. Another part that sticks out and that is obviously leveraged daily is the claim mitigation of having a digital asset being built or being updated as the project's being built. So not only do you get feedback as to via RFIs or change orders what was planned versus what was actual, but now that you have 3D components built into that communication channel, you can actually leverage the live project via Revit or whatever your 3D modeling software is to understand how you built it versus how you plan to build it. And I think there's another opportunity right there, if it doesn't already exist, to educate your scheduling solution via the as-built record of the digital twin, which is extremely valuable.
Great, thank you, Bart. Xingwei, value of the digital and importance of the digital twin.
Yeah, I think depending on how we define digital twin, right? From my perspective, there's no single definition. So I'll probably talk about a couple of values based on how you see that. The first perspective is visualization of the physical world in virtual world. So many times this itself creates a lot of value. You basically eliminate the physical constraint. You enable people in different locations to investigate some problem seamlessly. So this reduces the cost and improve the troubleshooting, and kind of the process, right? That's number one. Number two, many of peers here already talking about asset monitoring, just utilize sensing information, IoT, to try to duplicate what is happening in real world. Itself have a lot of value. Think about energy consumption, some performance. You have that kind of digital twin to help you create the insight of what's happening in real world. And many times you can come with a diagnosis strategy to help customer minimize downtime, right? The third one, which I feel like is more like an enhancement version of the digital twin, is not only duplicated the physical world, but you can have enhancement. I'll give you one example. Let's say filter you use on the real world. The digital twin is not only duplicate of that, but you can also bring the intelligence trying to say, hey, what is remaining useful life of that filter, which you cannot see directly from physical version of that. Then the customer can, I think we have a lot of college understand the benefit, right? Maintenance schedule, supply chain management. It's a tremendous value when you bring that kind of prediction into your digital twin. The things can go on and on. I just use this 3 simple version to just explain my perspective.
Great. Thank you to all of our experts on that. Right now, we're going to bring up a poll question. We want to get the audience involved and hear from you. So we'd like to understand from your perspective, why is the digital twin important to your business? And there are some common values here. We certainly heard even some more specific examples from our audience, but let's give people just a little bit more time. Still see some responses coming in. I want to make sure everybody has a time to share their views. All right, let's go ahead and put those results up. And I think what's interesting to see, there they are, that there are definitely, as Xingwei was saying, that there are different values and different types of digital twins. And it's interesting to see, a third drive it towards design and design decisions, and just about the same number, about a third, to drive continuous improvement. And a lot of that can come from even being able to bring data in from from the Internet of Things, and performance data as well as test data. I think what's interesting is in this poll question, you had to choose one. I think if we allowed people to choose more than one, I think we would see very clearly that there are multiple ways for value. Okay, let's move on. Thank you for participating in that. The next question for the group, and again, you know, there are different ways to get value from the digital twin, and we've really heard a lot about that really already. Starting, it could be simply modeling a physical asset, but extending well beyond that, as I said, even to connection to the actual device. Let's talk about whether digital twins are valuable even if you don't have simulation, before we go and understand that the value with simulation. And Epic Dave, I'm going to start with you this time.
Yeah, no, absolutely.
Because I like saying Epic Dave. I mean, it's...
Oh, who doesn't? Who doesn't? Sorry, non-Epic Dave. I think there's lots of values. It's just different value you could attribute to digital twins where simulation isn't involved. It's like looking at historical data. It's looking at current world data of how your building is currently operating. So there's certain insights you can gather depending on what data sets you have access to. You know, we see customers who are building digital twins for monitoring real-time states of power facilities or industrial sites, and knowing how machinery is performing or knowing how security is operating and giving a real-time window just into that. It doesn't have a simulation aspect, but it does have an operational aspect to it. And similarly, you know, simulation is the end goal, but to have simulation, you need to obviously build up a rich sort of back end of historical data. You know, that can be looked at in isolation as well, you know, make decisions or predictions, or even sort of make design decisions based off of what you know to have existed, not potentially what will exist or what simulation will look like in 2020. And, you know, what's great about those data sets is that the historic ones are available en masse in various different forms, and the present day ones, you know, you can get started with stuff like that with just an Arduino board and a couple of sensors in your facilities. So it's very easy to get started with them and work up to something like simulation. It's a good way of looking at it.
Great, even more Epic Dave.
Appreciate that. I think I couldn't agree more. As a, you know, I'm coming from a simulation shop, I guess. I hate to say there's value in digital twins also without simulation, but yeah, obviously there is. I couldn't agree more with what Epic Dave just said. We naturally, the organizations we are working with are, you know, we're naturally biased because we're seeing the organizations that think about, okay, we now want to leverage simulation for our digital twin solution, and they're at a point where they face challenges such as we don't just simulate the product design, we want to simulate the product instance in the field. And so it's different loads, it's a different way of thinking about simulation, and naturally, you know, scalability comes into mind, you know, and the issues where a cloud solution just helps. So that's why we're primarily seeing the digital twins that are already at a point where they can leverage simulation. But at this point, there's so many aspects before where I don't think it's more a journey for an organization to identify how, you know, where can we create customer value from a digital twin solution. And I think simulation is just an aspect in this, not the aspect.
Very good. Jingwei, can you share your views on digital twins without simulation?
Yeah, I think I'm on the same boat as previous to Debbie. I feel simulation's technology counterpart on the machine learning and AI starting to play a lot of role. And I'm very fortunate that my team, basically my team including mix of multi-physics background together with data science, data engineering. So I have a first-hand information to say, yeah, many times you get a lot of value just to use historical data or relevant data. You can build an AI model, and then that will give you a long way to go, right? So, but the certainly has some limitation. You know, we don't need to talk too much, but you say, hey, what if this is a new concept? What if this is a new application? What if we don't have any data? How you get started? Sometimes the first principle have their strong foot to help us. So,
Evert, I want to turn to you on simulations, and I think some of your examples didn't include simulation. So digital twins without simulation.
Yeah, I mean, obviously you get as far as how we were creating digital twins is from this little cup I got right here, Ferro laser scanners, right? So we set up these 360 laser scanners, plot them all over the job site. And what we did at the moment was post-tension deck for a 30-story high-rise in Chicago. You put the camera out there, pre-pour, so you get the post-tension cables, you get the rebar, you get the as-built of what's going to be in the concrete. And then once the concrete was flattened, we would scan it again so we can get floor flatness and levelness and deviations from design. 30 days later, we would scan it again to see what happened to the building after it's settled a little bit, so we can keep a benchmark of the quality of the completeness of the work in a 3D environment, and then also what happened over time. And then we would share that through recap, I believe, Autodesk Recap, to all the project stakeholders. They had equal access to the truth about what happened at what date. In that moment and in that time, that was our ability to reduce our risk of claims of having to do rework, because we could quantify with a non-biased third party, which was the digital twin, the exact quantifiable number even of the quality of the finished product of that concrete deck. That ended up itself being able to point towards that 3D model and 3D point cloud, the digital twin of the as-built, was our way to reduce, I believe it's quoted up to $150,000 per project, because we had something that couldn't be argued in this digital twin. That didn't involve any simulations whatsoever. I think later on in this conversation, we'll start getting into how to implement simulation to enhance what you've already captured. So I'll allude to that in a bit.
Sounds great. We're gonna get to that one next. Igor, if you could share your views.
Talking to me, right?
Yes, Igor.
Okay, so I think overall the digital twin is a journey, and adding simulation is one step in that journey, but it requires much more preparation that some people realize. We saw instances where kind of customers or future customers come to us and with a request to implement simulation without having real digital twin in place, and we coach them that even before you go to simulation, you can get a lot of insights into your real as-built product and the process if you build a digital twin and start with the aggregation of data, 3D visualization, etc., and then move to what-if scenario. So we see a lot of examples where even without simulation, digital twin brings very tangible and measurable, as ever pointed out, benefits and financial advantages to the projects and implementations.
Igal, if you would finish this round and help us understand the value of digital twins without simulation.
Sure. I can open and close any device in my house from anywhere in the world, right? I don't need simulation for that. I know every package when it arrives. So I think we all use it on a daily basis without even calling it a digital twin. Simulation comes in a much later stage on top of that.
I would agree. We're going to reverse the order this time, Igal. I'm going to come straight back to you. Using simulation with the digital twin can help in the innovation phase, validating design decisions, optimizing things, but also in the operational phase. Where do you see the value, some of the highest value of adding simulation on top of that digital twin? Maybe you're simulating your house lights.
No, from the 3D printing point of view, we have different technologies. In laser, you can get huge amounts of benefits. It's all about how many trial and error prints you want to do. In our binder jet technology, you cannot print without simulation because the distortions of the geometries are so big because of the scaling and the sintering process that it's a very tedious manual process to go through it. And we do this today, customers do this without, but the simulation tool is a game changer because you can reduce the trial and errors from 10, 20, 30 prints with hours and hours invested in tweaking different areas of the part. And more complicated the parts get, simulation is absolutely a must.
Yeah, tremendously high value there. Igor, what applications have you seen that have provided value of adding simulation on top of the digital twin?
The areas are quite diverse. It goes from the sales. We had a project where the simulation on the top of pretty crude but reasonably accurate digital twin allowed people to demonstrate to the future customers what's going to happen if they install equipment this way, that way, different types of equipment, and that basically speed up and kind of bring the completely different dimension to the sale process. On the other side is maintenance and upkeep of the existing assets and changing environment of kind of again brings a tremendous benefit for, but mostly our examples are in construction AC area where the changing of climate is simulated or changing of kind of wind pattern, etc., etc. So I think my conclusion that simulation added to the digital twin could bring benefits in some unexpected areas where people don't think about it sometimes. It's pretty widespread, I would say.
Ivart, if you can pick up from there.
Yeah, I think you guys kind of alluded to it a little bit earlier, but I have 3 examples that I'm seeing right now from contractors. The first one being energy modeling from the 3D BIM model and actually using what I would say an internal computational design system or a plugin for Revit to simulate the amount of energy that will be needed for the building to perform for 10, 20, 30 years with the existing specifications that were designed by the architect and engineers. We're talking about windows, drywall even, the HVAC unit, the plumbing, all of that being able to put out a report or a forecast of what's going to happen for the energy cost of that building for its life cycle, and then being able to manipulate those energy costs to change the designs. There's already a lot of startups right now tackling this. One that comes to mind is Alice Technologies, which is a computational design software that allows you to make 30 to 40,000 simulations instantaneously, and it'll spit out the best version of what the building should look like and how it should be built from a schedule standpoint. And leveraging information like this as far as before you actually break ground would save a lot of decision making long term that could have domino effects of the project either falling behind schedule or being over budget. And then another example I have is for one small example is volumetric computations for cut fill analysis. An example is we laser scanned the floor of an old church, and they asked us how much flooring compound would we need to get to 3 options of a floor height. And because the floor was so all over the place, we gave them cut fill ratios to get to a certain elevation in combination with the labor cost using a completely 3D workflow. So there's no guessing as far as how much compound we needed, how much time it was going to take based on the amount of compound, and ultimately where exactly on the floor within plus or minus a quarter of an inch that the compound will be needed, so you can have a heat map of what's going to happen. That's where we're at now with the technology that we have for duplicating or replicating what the existing environment looks like.
That's exciting.
Yeah.
Jingwei, maybe you can share with us the benefits of simulation on top of the digital twin.
Yeah, I think that's a great question. I will talk a little bit based on how rigorous we define the digital twin. So firstly, if we do the define loosely, like a digital twin, just duplicate the physical part. I think Donaldson Company, we actually extensively, I already talking about, our filter looks small but super complex, need a different technology. But also from life cycle of the product development, each cycle, you can see a lot of value by user modeling and simulation, right? Concept development, you're trying to come up with a new idea for innovation. The simulation help you tremendously to test the different concept and narrow down the direction, right? Design, all the different feature. I mean, we all know that very well. Validation, how many testing you need to do, sometimes it's extremely expensive to going validation after validation after validation on the test bench. But you use a simulation, that's save the cost and the time, right? Even for manufacturing, because we are don't leave manufacturing alone. That's a part of simulation capability. We need to duplicate it, some of the information and the manufacturing process. Sometimes it's very, very difficult to set up, take months to make it right. And the simulation will help a lot. And even then for the disposal, in use, troubleshooting, I think it's have a value on all the life cycle of the product development. But if you come to rigorous definition of digital twin, you're trying to bound into the real-time data, signature kind of things. I feel our simulation will be also very helpful to augment the data. Okay. For example, we have a called dust collector. You go to any factory or manufacturing floor, it's a very clean air because you see a big equipment on the side called dust collector, collect all those dust from the plant. So you can only measure so much, right? We have IoT, we measure certain pressure, flow, temperature, but you have an entire factory. How are you able to install hundreds of thousands of sensors if you really want to understand what's going on? It's very expensive. Simulation can help us expand it from limited measurement to unlimited prediction. So then you can help a customer solve their problem in the next level. So I just take a few examples. Really, depending on definition, I think it's really powerful tools for us. That's my point.
Yeah. Great, David Haney.
I'll give also 2 examples. We of course have a lot of examples in the design phase where real-world data from the field is being used in the design phase. But I think for us, when we talk about a digital twin, we typically talk about the operations use cases, and 2 examples of 2 very different scales. One, city scale. We do a lot of work in wind engineering, prediction of pedestrian wind comfort, wind patterns within a city, and we have a customer in Asia that predicts that has effectively combined meteorology measurements data with a prediction of what those hurricane measurements might mean for the city in terms of local wind patterns. So they are aiming at being able to connect weather measurements data and predict what will happen in the city in order to make more informed decisions about how they can respond to potential disasters, where areas might be affected. So really on a city scale, and then all the way to smaller electronics. We're part of a European-funded project, AI Twilight, where the goal is to build a fully featured digital twin for luminaires, for lighting systems deployed in cities, automotive, etc. Where the challenge really is that that there's so many different factors in lighting systems, from the lighting simulation, thermal, electrical, etc. And we're just a small portion of that, but it's also exciting to see what new use cases this will enable for lighting technology deployed in the field. So those are just 2 very operations use cases and 2 very different scales we're working on.
I'll continue. And just to wait up to say Epic Dave again. I think it is great about all these examples. There's this quote that I love, which is, if you think good design costs a lot of money, wait till you see the cost of a bad one. And I also want to just address the Q&A, because there was a question in there. It's like, why are we talking about design and construction? Does this not pertain to owners and operators as well? And so merging those 2 things together, I think the reason the simulation has such a benefit in the early design phase and in the kind of risk aversion phase is that it stops those big, impactful, costly things from happening, and it stops sort of projects being majorly impacted either by time, cost, or operationally down the line. So though there is value for the operator, I think there is a large calling back in this early design process, both from a city and urban planning scale, but also in the architectural design and design principle scale as well. You know, I think and this is why, you know, earlier on I spoke about, you know, getting access to existing data sets. And one of the things which is available in most cities are open data sets that pertain everything from pollution values to pedestrian to traffic to a whole host of things that, again, if we use correctly or we look at correctly, planning for future developments and planning and simulating potential developments which are going to happen in these areas can save a lot of cost, and it can impact the decisions that we make. So I think that's where, you know, we're going to see a lot of, or we are seeing a lot of people extending and looking at digital twins in that area.
Very good. Let's go ahead and we've got some really, really good questions coming in from the audience. So what I want to do is actually move forward a little bit in our question list, and I'm gonna take us to the question on getting started and advice, and we'll go back to our original order of the panelists. But I really want to understand. I mean, we talked about all of these different potential values for the digital thread. We talked about how simulation can help. You know, we haven't really talked a lot about the variety of different kinds of simulation that can help everything from 1D to full systems. You know, full system simulation. We've talked about. You know, I've heard multiphysics mentioned a number of times. So there's just a lot of potential and a lot of opportunity. So I'd like to step back and say, you know, to the people listening, what should we talk to them about? The first steps that they need to focus on to get more value out of the digital twins with simulation. I mean, what advice would you offer to somebody that is looking for a place to start? Igor, I'd like to start with you.
Yeah, thank you, Jim. And it's actually pretty common questions that we've been asked. People hear about digital twins, people hear about the benefits, and they come to us and say we want a digital twin. And as I said, it's more a journey than it's a clear definition of what it is. In very short term, it's somebody mentioned it's a digital copy of the physical object. And the first step in this direction is to collect as much data about this physical object as you can do and integrate it. And without it, any simulation doesn't make sense, because garbage in, garbage out is still there. The principle is still there. And we typically suggest to start small. We typically suggest to allocate the most important area to be digitized and start collecting data, start representing the physical object as much as possible, and verify that your representation is actually represented in reality and not just the aggregation of bad data. So the small steps, listening to advice from people who already did it is probably two major principles. Another thing that I also see people asking often, and I also saw a question in our list, is what tool can you recommend? Unfortunately, there is no one tool. You'd have to be ready to combine tools and create a kind of useful for you and economical, from business, economical, whatever standpoint, mix of tools that would get to a destination, or at least in the first, allow to create a first digital twin for the organization or project that they're working on.
Great. Yigal, what advice would you offer?
I think we're throwing digital twin on too generically, and behind digital twin there is still key questions that everybody needs to answer. Is what problem are we trying to solve, whom are we trying to solve it for, and why? And then digital twin, again, it's not a technology. It's like we're saying, it's the cloud. It will solve everything, right? It's an infrastructure, and it's an approach. And if we approach it in a traditional way of when you have a problem, you're trying to solve it and collect all the information why, it may lead itself to what approach you need to do, what tools you may need to do it, and it's a combination of approaches, a combination of tools. And there is no magic solution, as Igor said. There is no what's the digital twin tool you're using. It's not the same as you're saying which CAD system you're using, because the CAD system is very well defined in scope. Digital twin is a very broad approach.
Yeah, no, I couldn't agree more. I always say if you ask 5 people for their definition of a digital twin, you'll get 7 answers, right? Let's go ahead and move on to David Haney.
Yeah, I think the short here is I'm not sure if advice in such a generic way is really helpful, because I think I mean, Igal, you just said that the digital twins, it's a fuzzy concept, but even like where it is used is so broad, right? So for different use cases in different industries, for different assets. So I'm not sure generic advice is super helpful, but since I'm forced, Jim, to give one, I would guess like that the best practices of like ultimately one builds a digital solution, and so the best practices of software engineering discovered, apply here as well, sort of incremental and agile, which I think Igor alluded to, divide and conquer, right? Igor also said it, like small systems, open systems, like a tool for the job, connect them, and then go on this journey. So I think we're building a digital solution, and so there are certain best practices in software engineering have been uncovered over the last decades, and so I think those very much apply here. So that would be, I guess, the generic advice I would have.
Great. David McCall.
I wish I could give a different answer and say, well, to get started, go here and you'll have a digital twin out of the box. I actually have to reiterate what Igal was talking about. In the product management side, you always have to look back and address what is the problem you're trying to solve. In the AEC especially, we see a lot of this time with emerging technologies that people are so quick to jump on it, they really forget to ask themselves that question. We saw it with our early VR, where people were doing VR for VR's sake, but without actually looking at what solution does VR give us, which reality can't solve. And we have to address the same thought process whenever we look at digital twins and simulation. Is there something that we're looking to know? Is there a problem with my current process, or is there something that knowing would save me a lot of time and money? And sometimes the answers to these questions won't end with a digital twin. Sometimes they will. But I think once you start to break down that process, you'll be able to identify where is best to start, and also gives you a much higher likelihood of the benefit of that digital twin coming back to be good for you. Because the worst thing you'd want to do is create a digital twin or a simulation process for your digital twin, and at the end of it, you're no better off in understanding the problems that you're trying to address. So right back to the very beginning to go, why would I want a digital twin?
Yeah, start with the business first. Ebert, I see you already shaking, nodding your head. Why don't you continue on from there?
Yes, it's kind of interesting as far as specific to the construction industry's project delivery. Best use case of digital twins, right? About 5 years ago, you see Construction Site, which is a 360 photo documentation platform, come alive, and it gets adopted massively. It solved an issue that existed for, I'd say, generations, of documenting what happened on the project site and then being able to retrace it back to a specific date. That in and of itself replaced going through your file explorer, searching for a date, trying to remember where on the floor the picture was taken, who took the picture, if the picture was even the right location. That eliminated that entire workflow from existence. And now you see the emergence of like 7 or 8 different construction sites, or competitors to construction site. I use construction site because I worked with Philip Lorenzo back in 2016 when it was still in ideation phase. But that example of literally just taking a 360 camera and documenting what happened at a certain date and being able to retrace it at any moment allowed the physical digital twin of the as-built environment to be democratized to the entire project team stakeholders, which means their communication got more efficient. We saw it where we would do the same job walk once a week just to make sure that we were capturing things, even if we didn't need the data at the moment, or that we thought we didn't need at the moment, that actually saved us 8 to 12 months later on the project from being held responsible for an issue that was later discovered that we didn't recognize at the moment. That's the first iteration of the digital twin coming alive for the project delivery. I think what we're seeing now is the introduction of machine learning and AI for the same 360 photos that we've been capturing for 5 or 6 years, and now being able to understand geometries within the 360 image to actually say, this is a pipe, this is a drywall, this is how much exists on a floor. And then now we're going into what progress has been completed with these components that we've just captured in a 360 walk. And then leveraging that to validate payments and potential cash flow.
Thank you, Ebert. Jingwei, what advice would you give to people getting started with digital twins and simulation?
Well, the disadvantage of last speaker will be all the idea has been well explained. Right? So, but I will probably just recap a couple of things. It's more like my personal observation, right? I would say three things I think people can think about. The first one, I would say, consider hybridization of data and simulation. So we are living in the era of most valuable asset is data, not oil anymore, right? So data is coming more and more. We just need to be getting smart. So when you try to include simulation, consider the power of data, machine learning, and AI. Actually, there are many ways. Sometimes you think about, oh, some simulation can be replaced by AI. But also there's some very creative case, right? You're trying to let's create digital twins, and the simulation actually can create artificial artifact to allow you to utilize machine learning and AI to make you moving fast. There are many ways to hybridization of the both domain. I think that is the one thing I want people just don't forget. That's number one. Number two, I totally agree. Everybody said, I think understand business case, understand why you're doing that. Even though many times their engineering curiosity, including a leader like us and other engineering, try to, hey, let's try this one, very exciting, but understand why we're doing that. What is the value to customer and to the enterprise? I think that will carry us going much, much further, right? Other than become the 3 weeks or 3 months project and stop because we don't know why we're doing that. I think the last one, I use the same terminology actually called think big, start small. Okay, so this kind of thing is incredible complex, a lot of money if you're trying to build a skyscraper, sometimes let's take a agile approach, starting some simple pilot and get a result and show the result to other people, right? So you use that to as a demonstration to say, hey, this is going to be the value we're going to get. I think that is how to excite the entire organization and eventually get a bigger scope achieved. So that's a couple of advice from my side.
Great. I want to thank everybody on the panel. I'm looking through these questions right now, but I also realize I want to be respectful of everybody's time on the panel, but also of the guests. There is one very specific question that I'm going to share with you, Ebert. But then there's another one too about organizations and managing all the endpoints and data security. And I want to suggest that maybe data security is a topic we actually cover in one of these future executive seminars because it's such a big topic. But Ebert, for you, I'm just going to say, someone asked the question, can you speak to the role of GIS as a foundation connector of data, and data being CAD, BIM, survey, IoT, LiDAR, et cetera, for digital twins? Do you have a quick thought on that?
That's to me, right?
Yes.
Okay.
I thought you'd be the right one for that one.
Yeah, so we see, obviously, you have drones that have been capturing pretty good point clouds, really good images from the sky. But now we have, like I said earlier, the same thing that Struction Site uses for, or even Open Space Reconstruct Hollow Builder to simulate, or not simulate, to measure the amount of objects on the project can now be done from the sky. You have companies like AI Clearing that uses artificial intelligence to not only quantify the objects on a site, but once you start to do a repetitive scan, meaning you put a cadence into the capture, once every 2 weeks, once a month, and that captures the same thing, you can simulate how much progress is being completed. And with GIS implementing into that, you can basically use this for railway systems, highways and bridges, infrastructure, so on and so forth, to pinpoint that replica of data to that exact environment without having to set up a total station, or without having to set up your targets to actually locate the project to the plans or the coordinate system, which reduces the amount of time it takes to capture data. It makes it cheaper, and it allows drone pilots to pretty much go to any single project, capture data, send it up to the cloud, and have someone in the office do the analytics on it, which basically democratizes drones and allows drones now as one hardware to capture data to be used for that nature. So I think we're already seeing an emergence of that. I believe Ellis Don has a case study that's coming out, or maybe it's already released, about how they leverage AI clearing specifically in this use case to give an accurate representation of what the cash flow analysis should look like for cost to complete for the project years in advance, for a pretty big infrastructure project, which allows the owner to actually verify payments to the contractors, as well as reducing the likelihood of a post change order, meaning you paid them too early and they're asking for more money because they didn't actually do what you thought they did. This stops that, and this quantifies on a trade level what each trade did as a percentage complete compared to their contract value. I know I went a little bit deep on that, but there you go.
No, this is such a great topic. I think we could spend hours on it. I know people are going to have to run to other meetings and things, including our panelists. So I just want to thank everybody for joining us today. Thank you for your questions. We'll try and get back to each and every one of you on those directly. Thank you to the panelists for taking the time to prepare and to be here for this. And also thank you to AMC Bridge for bringing this together and organizing this. It really is a valuable series, and looking forward to the continuation of it. I hope everybody has a great day, evening, whatever it may be.
Thank you.
Everyone.
Thank you very much, everyone.